for another class, and it seemed to work out all right, but we'll see how this goes. So we're live. We go on YouTube for billions to hear, listen. The infamous period 6, Mr. Samuelis's little math world. All right, so let's go to the two-term column. Now remember what factoring is, guys. Factoring is the reverse of what? What's the factoring the reverse of? Distributing, multiplying, foiling. You okay here, student number? Yeah. Okay, so it's the reverse of multiplying, the reverse of foiling, distributing, so on and so forth. So let's jump back real quick. In all factoring cases, all you all better realize that you need to look for a GCF first before you do anything. Okay, so I'm going to ask that annoyingly every little question that we have up on these notes here. Do we have a GCF? If not, then we move on to the next thing. Do I have 2 terms? Do I have 3 terms? Do I have 4 terms? And then because I have that, what should I look to do? All right, well, the first column is 2 terms. So the first example represents a difference of 2 squares. Why is that? Well, first of all, difference implies what operation, everybody? Starts with an M. M-I. M-I-N. M-I-N-U, there's only one letter left. Minus. So we have a difference of 2 squares. Okay, student number right here. What's the perfect square of 64? Come on, you're live, man. This is YouTube. 8. What's the perfect square of 81? He's getting the calculator out. Times tables 9. So, yay! I love that. All right. So we're going to get that message come up a lot during this. So, what's the perfect square of 64? X squared. 8 what though? X squared is what times what? No, 8. And then what's the perfect square of x squared? No. At what times what equals x squared? X. Don't let me, Smalls. All right. What's the perfect square of 81? 9. Let's move this along. What's the answer? So I'll pause the movie for a second. Okay, so student number 2 remembers the pattern for difference of 2 squares. The perfect square of the first, perfect square of the second, plus minus. Here's why. What is this the reverse of? Multiplying. Now circle this answer. It's over. What I'm going to do is prove it. Hey, all you all, what's 8x times 8x? 64x squared. Do not write this. This is checking your answer. This is the reverse of what you just did. All right, now I always do this. What's 9 times negative 9? I'm going to write it all the way over there, negative 81. Because then what happens to the middle term? They cancel. This is minus 72x. This is positive 72x. Lo and behold, I end up what I had for the question. So I'm going to talk about that class again, that Foundations of Algebra 2. Those students learned that pattern, and then I was able to ask them ridiculous questions like this, and they were fine. Are you ready? They were able to be asked 121 x to the 6th, yes, that's true, minus, oh, what did I throw in the other class? Let me think. I can't think of my squares right now. This is embarrassing. 169, there we go, and I just hit that thing. Y squared. Because it doesn't matter. All it is pattern recognition. This is a difference of, well, is it 2 perfect squares? What's the perfect square of 121, is it? 11. But wait a minute. It's x to the 6th. What's the perfect square of x to the 6th? What times what equals x to the 6th? X to the 3rd. He's right. Do number 6. What's the perfect square of 169? 13. That's going to happen about 74 more times. And then what's the perfect square of y squared? Y. I can't. So what is this in factored form then? It is 11x cubed minus 13y. Got to be right in here, Chief. Can't write for you. And then 11x cubed plus 13y. They had those questions. It was a class that the same exact level of what we're dealing with in here. Because all it was, okay, I recognize that as a difference of 2 squares. The pattern works, right? And that's what I memorized. And that's what we need to do in here, okay? So now what's the next type of thing you could have? The sum of two what? What gives away that this is cubes? The x to the third. I mean, come on, you cannot confuse this with the last example. It's impossible, right? There's no way you could do that. So this is the sum of two cubes. I'm going to prove this when we actually are done with this. What is the perfect cube of 27? 3, but it's 3x, right? I didn't say that the right way. What's the perfect cube of 27x cubed? It's 3x, 3x, 3x. What's the perfect cube of 8? 2. Now, we had that acronym for this. I'm going to write this way. SOAP. S-O, and then it's AP. So what that implied was we have a binomial, and this is what the signs are, and then this is a trinomial, and this is what the signs are between all of the terms. So this factors to a binomial times a trinomial is what we needed to remember. So what goes right here? Okay, what goes right there? 3x. Now, what does that S mean? Same. So what's the sign right here? Plus. And then what goes right here? Not 8. 2. The perfect cube unit, if you want to call it that. And then what goes here? What do we put right there? What do we do to the 3x? We square it. So what's 3x squared, everybody? It's 9x squared. Square the 3, square the x. Then what does this O stand for? There it is again. Opposite. So what do I put for a sign here? You play with your hair. Pay attention. Okay? What's the O stand for? Minus. Opposite of plus. And then what do we do in this middle term? Not add them. We actually do what with these two? Multiply them. So what is 3x times 2? 6x. And then what do we do? What's AP stand for? Always positive. And then what do we put at the last blank? What do we do to the 2? Square it so it is 4. Now, that is the answer. So I'm going to get rid of the SOAP for a second because I'm going to check this. All right, so that is it. Now, why is this true? Well, here's a couple things you should do. First thing is what's 3x times 9x squared? What's 3 times 9? 27. What's x squared times x? X cubed. And then go to the last. What's 2 times 4? 8. And then what's going to happen to every term in the middle? They will cancel out. I'll bore you by showing you that. This is negative 18x squared. This is positive 18x squared. Gone. And then I have one more line to show. 3x times 4 is 12x. Just writing it weird. But then this is negative 12x. So that's gone. So that is why this works, because factoring is the reverse of foiling. So yes, that crushed, destroyed class back in the day, we actually did questions as nasty and bad as this. 125, I'm going to do this again, mess with your mind. X to the 6th plus 216 y to the 3rd. All they needed to do was recognize that this was a sum of two what? Cubes. What's the perfect cube of 125? What times what times what equals 125? 5. What times what equals x to the 6th? Don't just show this message. I've tried that before and it still comes up. We'll see. What's the perfect cube of x to the 6th? X times what times what times what? X squared. 216. What's the perfect cube of 216? You're not paying attention back there. I know it. Okay. What's the perfect cube of 216? Anyone know? It is 6. But 6 what? 6 what? 6y. It's 6y times 6y times 6y. Stay up here. Okay, so what does this become? 5x squared, SOAP, plus 6y, SOAP. O for SOAP. Okay, what do we do with 5x squared? We square it. What's 5 times 5, everybody? 25, and then what's x squared times x squared? X to the 4th. This is exactly what they were able to do, and it was not a big deal. Once they got the patterns down, it didn't matter what kind of question we were asking. And then what do we do for the middle term? We multiply those. What's 5 times 6? Now, SOAP, same opposites, and then it's 30 x squared y. And then the last term was square that 6y, which is 36y squared. All right, I won't get that difficult on the difference of cubes. You should get the point at this time. And actually, this example, I actually did get a little bit of a challenge on it. All right? We already said this. What's the perfect cube of 125? What's the perfect cube of 125? 5. But x to the 6th, x squared. So what we're saying is 5x squared times 5x squared times 5x squared. That's a perfect cube. What's the perfect cube of y to the 9th? What times what equals y to the 9th? Y to the, it's actually to the 3rd. Y to the 3rd times y to the 3rd times y to the 3rd. Okay, so again, SOAP, same, opposite, always positive. Binomial times trinomial. We're not going to bore you with checking your answer. Okay, so what's the first set of parentheses? Let's go offline and get someone in. Okay, then what goes here next? We take this and square it. So what does that become? 25, x to the what? 4th. And then opposite of minus. So what goes here? Plus. And then what goes in this middle term? These two multiplied together, which is what? 5x squared what? Smoosh them together. And then I'm going to move this parenthesis off to the side. And then what's the last term? Always positive. Okay, so it's y to the 6th. Y to the 3rd times y to the 3rd. All right, I said I wasn't going to bore you, but that's too late. At least check this. When I take these two and multiply them together, I get that first term. Take these and multiply them together, I get that last term. What's going to happen with all the other terms? They're going to cancel if you are going to check your answer, what this factoring is all about.